Now we'll see the Poisson distribution. The PMF, probability mass function of Poisson distribution, is P of x is equal to x, or again P of x, that is e power minus lambda, lambda power x by x factorial, where x is greater than or equal to 0, where that lambda is given by n into p, where lambda represents mean or average, n represents number of trials, and p represents probability of success. So here, in case of Poisson distribution, you can say that note mean or average is given by lambda directly, lambda. So similarly, variance sigma square is given by lambda again. Standard deviation is under root of lambda. So we can derive all these things by applying that. So we know that mean of any discrete distribution is given by mean is equal to summation x into p of x. So here summation mean is given by summation x into p of x. That is equal to summation x into p of x is e power minus lambda power x by x factorial. So here x is equal to 0 to n. So simplify this one, finally it gives lambda. Similarly, variance. Since it is a discrete distribution, you can write variance is equal to, here mean is expectation of x, variance is expectation of x square minus expectation of x whole square. That is equal to summation x square into p of x minus mean whole square. There is a summation x square into p of x. P of x is e power minus lambda power x by x factorial, minus mean is lambda square. So if you simplify this one, again it will give you finally lambda only. So in case of the important observation here is, in case of Poisson distribution, mean and variance are same. Mean and variance are equal to same lambda, but whereas standard deviation is equal to square root of lambda. That is a positive square root of lambda. And now we'll do problems on Poisson distribution. The number of accidents occurring in a plant in a month follows Poisson distribution with mean as 5.2. The probability of occurrence of less than 2 accidents in the plant during a randomly selected month is. So it is given that number of accidents occurring in a plant in a month follows Poisson distribution with a mean as 5.2. So mean of Poisson distribution is lambda, that is given as 5.2. The probability of occurrence of less than 2 accidents. So here p of x less than 2. Here x represents number of successes, here number of accidents. In this problem, number of success nothing but number of accidents. Here less than 2 accidents, where x represents number of accidents, less than 2 accidents in a plant during a randomly selected month is. So less than 2 accidents. So we know that p of x is equal to x, that is the probability mass function of Poisson distribution is e power minus lambda power x by x factorial. So applying that, so p of x less than 2. Less than 2 means again p of x is equal to 0 plus p of x is equal to 1. Using that PMF of Poisson distribution again, that p of x is equal to 0, e power minus lambda minus 5.2 whole power, here x value 0 by 0 factorial, plus e power minus 5.2 whole power 1 by 1 factorial. So simplifying this one, finally it gives 0.034. Option B is correct for this problem. Now come to that second question. An observer counts 240 vehicles per hour at a specific highway location. Assume that the vehicle arrival at the location is Poisson distributed. The probability of having one vehicle arriving over a 30-second time interval is. So an observer counts 240 vehicles per hour at a specific highway location. Assume that the vehicle arrival at the location is Poisson distributed. The probability of having one vehicle arrival over a 30-second time interval is. So here, observer is counting 240 vehicles per hour. So this is a lambda here. Lambda is 240 average value, 240 vehicles per hour. But here we require probability of having one vehicle arriving over 30-second time interval. Probability of having one vehicle arriving over 30-second time interval means we have found out that the lambda value per 30 seconds. So this is a lambda value per 1 hour. So we get here 240 by 60 vehicles per minute. We require lambda value per 30-second time interval. So 240 by 60 means we will get 4 vehicles per minute, which is same as that is equal to 2 vehicles per 30-second time interval. So here we are getting 4 vehicles per minute means you can say average lambda is equal to 2 vehicles per 30-second time interval. So this is the lambda which is to be used here. Now we require here probability of having one vehicle arriving means P of x is equal to 1. So vehicle arriving is here a probability of getting success. So P of x value 1. We require only one vehicle arriving. So using that PMF of Poisson distribution, e power minus lambda power x by x factorial. So e power minus lambda here, lambda value 2 is a 2 vehicle per 30 seconds into 2 power lambda value 2 x value 1 by 1 factorial. So we get 2 by e square, that is approximately equal to 0.27. Approximately equal to 0.27. This is the solution for the second question. Now come to the third question. If x is a Poisson random variable and given that e of x square, that is expectation of x square is equal to 6, find the variance. Find the variance. Here x is a Poisson random variable. So we know that in case of Poisson distribution, mean and the variance are same. Mean is equal to variance in case of Poisson distribution. So it is given that, see, we know that what is the variance here, variance of random variable, any random variable x is given by e of x square minus e of x whole square. In terms of expectation, variance of any random variable v of x is e of x square minus e of x whole square, where that e of x represents mean or average. So in case of Poisson distribution, mean is equal to variance. Let mean is equal to variance is equal to some x. So it implies again that x is equal to, here it is given that e of x square value 6 minus e of x. E of x, that is the mean value. Mean is mean and variance both are equal to x here. So we get x square. So it implies we get x square plus x minus 6 is equal to 0. X square plus x minus 6 is equal to 0. That is the quadratic equation in x. Solving for roots, we will get x is equal to 2 minus 3. 2 minus 3, but we have to ignore here negative value because variance cannot be negative. Variance cannot be negative. So the variance value is 2. The variance value is 2. That is the answer for this question. Next problem on Poisson distribution. If x and y are two independent Poisson random variables such that p of x is equal to 1 is equal to p of x is equal to 2, p of y is equal to 2 is equal to p of y is equal to 3, then find variance of 3x minus 4y. So 3x minus 4y. So to find variance of 3x minus 4y, see variance of 3x minus 4y using that property we have variance of ax plus or minus by, where x and y are any two random variables and a and b are constants, is given by a square variance of x plus b square variance of y, here where x and y are independent. X and y are independent. It is given that two independent Poisson random variables. So we can go for this formula, variance of ax plus or minus by, where x and y are independent. So to apply this formula, we require variance of x and variance of y. So we have to find out variance of x and variance of y. So from the given conditions, what is the given condition here? P of x is equal to 1 is equal to P of x is equal to 2. So P of x is equal to 1. So applying that PMF of Poisson distribution, e power minus lambda, we don't know that lambda value, e power minus lambda power 1 by 1 factorial, that is equal to e power minus lambda square by 2 factorial. So e power minus lambda will get lambda square will get, so we get lambda value 2, lambda is equal to 2. So lambda is equal to 2 means I can say that what is the mean of, that is the expectation of x or mean of x is 2. What about variance of x? Variance of x is also 2, because in case of Poisson distribution, mean is equal to variance. So similarly, solving that second one, P of y is equal to 2 is equal to P of y is equal to 3. It implies e power minus lambda square by 2 factorial, e power minus lambda cube by 3 factorial. So simplify this one, we get lambda value 3. Lambda value 3 is expectation of y. The mean of y series is 3. So variance of y series also 3. So since it is a Poisson distribution, in case of Poisson distribution, mean is equal to variance. Now therefore, the required thing is variance of 3x minus 4y. You can take small x or capital x for ordinary. Variance of 3x minus 4y, that is equal to, apply this formula, a value 3, here b value 4. So a square, here 3 square variance of x plus 4 square variance of y. So 9 into variance of x is 2, plus 16 into variance of y is 3. So we'll get 18 plus 48, that is equal to 66. So variance of 3x minus 4y is 66. This is a solution for that fourth question. Now we'll come to that fifth question. If x1 and x2 are two independent Poisson random variables with variances 1 and 2 respectively, find P of x1 plus x2 is equal to 4. So how to find this probability value? P of x1 plus x2 is equal to 4. Given that x1 and x2 are two independent Poisson random variables. Here we have one property. If x1, x2 are two independent Poisson random variables, it implies x1, the sum also, x1 plus x2 is also Poisson random variable. x1, x2 are two independent Poisson random variables, then their sum also Poisson random variable. Similarly for binomial also, if x1, x2 are two independent binomial random variables, the sum x1 plus x2 is also binomial random variable. So here applying this property, I can write P of x1 plus x2 is equal to 4, is equal to e power minus lambda. What about PMF of Poisson distribution probability mass function, e power minus lambda power x by x factorial. So you get e power minus lambda 1 plus lambda 2, because the sum also x1 plus x2 is also Poisson random variable. is also Poisson random variable, so I can apply that formula. E power minus of lambda 1 plus lambda 2 plus lambda 1 into lambda 1 plus lambda 2 whole power 4 by 4 factorial. Now, so it is given that variances are 1 and 2. So in case of Poisson distribution, we know that mean is equal to variance. So mean is equal to variance. So lambda 1 is equal to 1, lambda 2 is equal to 2 will get. Since mean is equal to variance in case of Poisson distribution, lambda 1, 1, lambda 2, 2. So it implies e power minus 1 plus 2 into 1 plus 2 whole power 4 by 4 factorial. E power minus 3 into 3 power 4 by 4 factorial. So this is the solution of this question.